Recently, a groundbreaking discovery has sent shockwaves through the scientific community and the world of space enthusiasts alike. Bill, a celebrated science communicator, made a startling announcement that Voyager 1, the venerable spacecraft that has been journeying through space for nearly 5 decades, had detected an astonishing 300 massive objects in the vast expanse of space. This revelation has not only sparked a surge of curiosity but also raised profound questions. What exactly are these objects and where did they come from? How do they fit into the larger cosmic puzzle? Join us as we embark on an in-depth exploration of the mysteries these objects may hold, and how they contribute to our understanding of the vast, unknown universe beyond our solar system. For nearly 5 decades, the Voyager missions have provided humanity with some of the most extraordinary and revelatory images and data about our solar system and beyond. But perhaps the most surprising thing about these missions is that they were never intended to last this long. In fact, when NASA launched Voyager 1 and Voyager 2 back in the summer of 1977, they were expected to last only 5 years. Their mission was supposed to focus on the planets Jupiter and Saturn, providing humanity with detailed studies of these colossal gas giants. And yet, the Voyager spacecraft have far exceeded those initial expectations, continuing to transmit data and fuel scientific discoveries even as they venture farther and farther into the unknown reaches of space. The story of the Voyager missions begins with a revolutionary idea proposed by scientist Michael Minovich. He discovered that spacecraft could use the gravitational pull of planets to gain speed and continue their journey further into the solar system. This discovery unlocked a new way of exploring space and dramatically reduced the time needed to reach distant planets. This concept, known as gravity assist or slingshot maneuver, became the backbone of the Voyager mission, allowing these spacecraft to explore planets that were once considered far too distant to reach. Launched just weeks apart, Voyager 1 and Voyager 2 embarked on their journey with one primary task: to explore Jupiter and Saturn. And in 1979, they succeeded. Voyager 1 provided unprecedented views of Jupiter's tumultuous atmosphere and complex system of moons. Voyager 2 went on to conduct the first-ever close-up observations of Uranus in 1986 and Neptune in 1989. These flybys revealed unexpected secrets, such as Neptune's mysterious moon Triton, which featured geysers spewing nitrogen at temperatures near absolute zero. But the Voyager missions were not content to stop at the outer planets. With their sights set on a more ambitious goal, the spacecraft set their path into the far reaches of space. These missions were truly a grand tour, and instead of winding down after their planetary explorations, they continued into uncharted territory, the deep space beyond our solar system. Fast forward to 45 years later, and both Voyager 1 and Voyager 2 are still journeying through space, continuing to send invaluable data back to Earth. In 2013, NASA made a monumental announcement: Voyager 1 had officially entered interstellar space, beyond the magnetic influence of our Sun. This marked a historic milestone in space exploration, as Voyager 1 became the first human-made object to ever cross this boundary. Interstellar space is the vast, star-filled void that exists between the stars, where the Sun's solar wind no longer dominates. This was a monumental moment for humanity. Voyager 1 had left the protective bubble of our solar system and stepped into the great unknown. In 2018, Voyager 2 followed suit, also crossing the boundary into interstellar space, becoming the second spacecraft to ever achieve this feat. Voyager 1 and Voyager 2 are now traveling through this mysterious and largely unexplored region of space, far beyond the Sun's influence. They remain the only spacecraft to have ventured this far, gathering essential data on the interstellar medium, the matter and energy that exists between the stars. These two spacecraft have become our most crucial instruments for studying the outer boundaries of the solar system and beyond, offering us insights into the nature of the cosmic space that surrounds us. Perhaps the most fascinating discovery to come from the Voyager missions is the heliosphere, a vast bubble that surrounds the solar system, formed by the Sun's solar wind. This bubble acts as a cosmic shield, protecting our planet from much of the harmful cosmic radiation that permeates the galaxy. Voyager 1 and Voyager 2 have been instrumental in helping us understand the shape and size of this protective shield, and how the solar wind interacts with the interstellar medium beyond the heliosphere. One of the more surprising revelations from the Voyager missions occurred in 2023, when Voyager 1 detected an unexpected low humming sound, a faint vibration in the gas drifting through interstellar space. This discovery helped scientists better understand the movement and behavior of this gas, providing a new piece to the puzzle of how our solar system interacts with the vast expanse of the universe. And yet, despite the incredible data the Voyager spacecraft have sent back to Earth, their longevity remains an extraordinary feat of engineering. Powered by plutonium-based systems, the spacecraft have slowly been losing power as the plutonium decays over time, gradually reducing the energy available to run their instruments. To cope with this, NASA engineers have had to make difficult decisions, shutting down non-essential systems and even turning off the heaters that keep the instruments warm in the freezing void of space. Despite these challenges, the spacecraft's 5 key instruments have continued to operate since 2019, far surpassing anyone's expectations. What's even more mind-blowing is that these spacecraft are still transmitting data despite being in one of the coldest, most hostile environments imaginable. The fact that they have remained operational for so long is a testament to the ingenuity of NASA engineers who continue to defy the odds. In fact, scientists are still baffled by how the Voyagers continue to operate after nearly 50 years, as most other spacecraft would have long frozen up under such extreme conditions. Beyond the spacecraft's power issues, another aspect of the Voyager missions that has captured the attention of scientists is the heliopause, the boundary that marks the edge of the solar system's influence. This boundary is not static, it shifts and fluctuates over time, making it even more challenging for scientists to understand. Over the past decade, data from Voyager 1 and Voyager 2, combined with information from NASA's Interstellar Boundary Explorer, IBX, has revealed that the heliopause is much more dynamic than previously thought. The position of the heliopause has been shifting in strange ways, suggesting that interstellar space is not as uniform as scientists once believed. These shifts in the heliopause have raised many questions and sparked debate among scientists about what exactly is happening at the outer reaches of the solar system. In May 2023, Voyager 1 experienced a peculiar event. The spacecraft's Altitude Articulation and Control System, ACS, which manages the spacecraft's high-gain antenna, began sending back strange, incoherent data. For a moment, it appeared as though Voyager 1 was encountering electronic malfunctions. The data seemed erratic, almost as though the spacecraft was losing its mind. But despite the strange data, Voyager 1 continued to operate normally, sending strong and stable signals back to Earth. NASA engineers quickly identified the source of the problem. It turned out that the ACS was using an old computer that had been inactive for years, causing the confusion. With a simple command, NASA switched the spacecraft to a functioning computer, restoring normal operations. However, the cause of the strange behavior remains a mystery. Did cosmic rays cause a glitch in the system? Or was it a software issue? While the mystery remains unsolved, this incident is just one example of the challenges faced by the Voyager spacecraft as they navigate uncharted space. Voyager 1 and Voyager 2 were never meant to journey as far as they have, but through a combination of innovative engineering, a bit of luck, and groundbreaking discoveries, they continue to defy expectations. As they move further into interstellar space, they offer humanity a glimpse into the unknown and provide insights into the very nature of the universe itself. Nearly 50 years have passed since Voyager 1 and Voyager 2 embarked on their historic journeys that have taken them across vast distances, exploring distant planets and the mysteries of deep space. Despite their outdated technology, with onboard computers that had just 70 kilobytes of memory, a fraction of what modern digital watches have, the Voyagers have outlived all expectations, continuing to provide valuable data about the farthest reaches of our solar system. Let's take a moment to appreciate these extraordinary pioneers of space exploration. The twin Voyagers, drifting endlessly among the stars, continue to push the boundaries of human knowledge. Their legacy will endure for generations, reminding us of the boundless curiosity and relentless perseverance that drive humanity to explore the unknown. What do you think about these latest findings from the Voyager missions? Let us know in the comments below. If you enjoyed this deep dive into space exploration, don't forget to like this video and subscribe for more exciting updates about the wonders of the cosmos.